All right, here we go. State whether the function has an inverse, and if it does, if that inverse exists, find a rule for the inverse. Then state the domain and range of both the original function and its inverse. So um, here we have f of x equals the cube root of x, and this one it will have an inverse. If you think of the cube root of x. Uh, don't get tricked into thinking, no, since we can plug negative numbers in here, and so this is not going to be a function. This isn't going to work. And it's a cube root, so it's perfectly okay if we um, have negative numbers inside of here, because the negative cube root of, for example, of the cube root of -1, for example, what times itself 3 times gives me the -1? Well, -1 does, and that's so lately we've been having a bit of confusion about that with the cube roots versus square root. So if it's a odd root, we're perfectly okay with putting negative x values in. It's just when we have an even root and the x values need to be positive. So that'll being said, it does exist, and so let's write the rule for it. So if I have, I'm going to write it as y equals the cube root of x, and swapping our x and y, so x equals the cube root of y. I'm going to switch, or sorry, now solve for y. And so let's cube both sides, and that gives us y equals x cubed, and really not y, but f inverse of x. All right, so there's our rule. And now state the domain and range of the original function and its inverse. And so of the original function of f of x, we've got, which again was, let's see, what was it? The cube root of x. The domain, we've got all real numbers, and the range is, again, all real numbers. For the inverse, f inverse of x, which is x cubed, our domain here is also all real numbers, because that was the range of our f of x, so then that's going to be the domain for our new one. And then the domain, or sorry, the range is all real numbers, which makes sense because that's the domain of our original function. So all these values, if we plug them back into, should be able to plug them back in as domains into f of x. All right, and so then now we've got f of x equals the cube root of 5 minus x. And so does this one exist? And the answer is going to be, yeah, this looks kind of like a, you're going to head over to +5, and it will, that's pretty ugly. It'll look like kind of half a parabola opening to the left. And now there's no negative values over here, because how would I get a negative out of the square root? My output has to be positive. We don't have any negative y values here. And so it does exist, the inverse. Let's go ahead and find it. So if we start off with y equals the square root of 5 minus x, our inverse is going to be x equals the square root of 5 minus y. Square both sides, and we get x squared equals 5 minus y. Add 5, subtract 5, add y, however you want to think of this. We'll get, let's go and subtract 5. So we get negative y is equal to x squared minus 5. And lastly, we'll go ahead and multiply everything by -1, or divide everything by -1, and get y is equal to negative x squared plus 5. Sorry, just 1 second. All right, which we had y, I believe, and so remember it's not, that really is the f inverse of x is equal to negative x squared plus 5. And there's our inverse. We've written our rule right now. All right, and so find the rule. Now state the domain and range of the original function and its inverse. So let's go ahead and do that now. That on the original function, on f of x, we had that this is equal to the cube root of, it's out of our way, the square root of 5 minus x. And my domain here, I can plug in all real numbers that are less than or equal to 5. I can plug in 5 for x, that's fine, that gives me 0 in my square root. But I can't plug in numbers like 6 because then I'll have 5 minus 1, or 5 minus 6, which is negative 1. I'll have some imaginary numbers. So now the domain is going to be that x is less than or equal to 5. And its range, and we talked about that at the very beginning, there's no way for me to get any negative output here. So I'm going to have y is greater than or equal to 0. As we come over to the inverse, so f inverse of x we have, which negative x squared plus 5. My domain here is what my output was on my previous function. So my domain is going to be that x is greater than or equal to 0. And my range, could cheat a little bit and see how my range would be the same as my x value, but let's think through this for a second. I can, what is the highest value? Now this is kind of looking like a parabola that's opening downward, but it's just the one half of it where the x values are greater than 0. The highest value I can get is 5. So I'm going to have y is less than or equal to 5, which again makes sense. That's our domain for our original function. So I hope that helped.